So today I'm going to construct a parallelogram. Let me see if I can write it. Parallelogram ABCD. And my parallelogram is going to look something like that. A, B, C, D. Now I promise you what I end up with isn't actually going to look like that, but you get the idea. And I'm going to set, I have to decide how I'm going to construct this thing, what my limitations are. And what I'm going to do today is determine in advance the length of diagonal DB and the length of diagonal AC. So over here I'm going to give myself a couple of what I call a bag of parts. So I'm going to construct the larger diagonal, AC, and the shorter one, BD. And the property of a parallelogram that I'm going to make use of to do this is the property that says that the diagonals bisect each other. So I'm going to have a point over here where those diagonals intersect, and I'm going to need to know where the midpoints of my diagonals are. So I'm going to do the midpoint construction, which is really a perpendicular bisector construction for each of these segments. So I put my compass point on one end, swing two arcs above and below, go to the other end, ditto. Need to dodge around my tripod. And I'll do this one. Now the length of my compass when I do this, it doesn't really matter as long as it's greater than, comfortably greater than 1/2 the length of the segment that I'm trying to bisect. And you may hear in the background of this video, I've got a rabbit loose in the room, hopping around, generally making a pest of itself. So there's the midpoint of AC, and then I'll line up my straight edge on these crosses for the second one. And there's the midpoint of BD. So now I'm going to do something really surprising. I'm going to set my compass up for the radius of a circle, and I'm going to set my radius equal to 1/2 of AC. I'll make sure I really get the midpoint here. That looks pretty good. So compass point goes on this point that I've decided is going to be where my diagonals cross. And I'll construct a very neat little circle. I'll set my compass up on the other one. 1/2 that. Let's see, am I really getting this right? That looks pretty good. So I'll go over here, compass point in the center of my circle, and I'm going to construct a concentric circle. Alright, now you're saying, why on earth did he do that? He has two circles. Nowhere near here are you going to find a parallelogram. Well, here's the trick. I'll take my straight edge, lay it across my circle, line it up with the center so I've got a diameter for the circle. I'll make a mark on either end on the large circle. Now I'll pivot this any old way I want, line it up in the center point again, and I'll mark the endpoints of the diameter on the smallest circle. Now the distance from here to here is equal to BD. The distance from here to here is equal to AC. And these two segments, when I finish them, will bisect each other. So they should be the diagonals of the parallelogram once I hook up these endpoints, which I'll name A, B, C, and E. So let's see how it works. Trusty straight edge. And before your very eyes, the parallelogram begins to appear. Now, you have to rotate a little bit and imagine it lining up with that, but you see basically I ended up with what I was intending to. if I were doing this in GeoGebra or another computer program, at this point I would go in and right-click on the circles and make them disappear. I don't want them anymore. I needed them, or I used them to construct the thing in the first place, but now they're just extraneous. I'm using pen and paper, so I'm kind of limited there. But you can see from those circles I have constructed a very neat little parallelogram. So there you have it, parallelogram ABCD.